What's up, everybody? So today we're looking at 2.5 like terms. All right, we got into some like terms in the last lesson. If you guys remember, we're going to dive a little bit deeper today. But before we do, I'm going to have you guys try out a warm up dealing with what we were learning yesterday, which was just basically simple multiplication rules. All right, so go ahead and take a minute to copy this down, try out these two problems, and then we'll go over it together. Okay, try it out. Okay, so yesterday you guys probably remember, multiplication rules, something that you've definitely learned in the past, though, it's nice to have a little refresher. So taking a look at number one here, we got three numbers being multiplied. First reminder, I guess, we can multiply these numbers in any order. I could do -9 times -2 or -9 times -5. It doesn't matter when we have just a bunch of multiplication, just so you know. All right, so I'm going to choose to multiply the -2 and the -5 together, okay? Because I know a negative times a negative gives me a positive, so I got a positive 10 there. So I got I'm going to bring down the -9. This is turning into a positive 10, okay? Those are nice, easy numbers, and, a negative times a positive is always a negative, so we're going to be getting a -90. Easy enough. All right, taking a look at number two here. The other part of our lesson was distribution, which is just more multiplication. But when we multiply a number times, I guess a few terms in a parentheses. All right, so you guys remember what's outside is going to be multiplied by all of the terms on the inside, and it looks like we have two of them here. And so let's go ahead and do it. -3m times m. Okay, well, there's nothing for the -3 to be multiplied by, though, technically there's an invisible 1 in front of that m. Okay, but either way, we're getting a -3. M times m, we're getting m squared. Okay, moving on to the next one, -3m times -5. Well, -3 times -5 is a positive 15. That m doesn't have any other m's to multiply with, so, kind of just tags along. Okay, and just taking a look at this, I just remind you guys, always look to see if you have any like terms. Can I actually add these two terms together? Okay, and the answer is no, because these are not considered like terms. And if you're not sure why, we'll get into that on the next slide. Okay, so there's a little summary of yesterday. Let's get into what we're doing today. All right, so terms and coefficients is what we're starting with here. So go ahead and take a second, get the title at the top of your paper like you always do. Remember, the warm-up is part of your notes. You don't need to do it on a separate sheet of paper or anything like that. Okay, so yeah, go ahead, take a minute, copy down this slide here, terms and coefficients, and then I'll explain it in just a second. Okay, so yesterday I pointed out that a term, the easiest way to identify a term is to just know that terms are separated by addition or subtraction symbols. All right, and yeah, we already have it highlighted here. We can see we have a -3x squared, a positive 2x, and a -4. We have three different terms here. Okay, there's a few other things. Sometimes you'll see the word coefficient. Okay, and the easiest way to think about a coefficient is that it is the number in front of a variable. All right, so 2 would be considered a coefficient, and -3 would also be considered a coefficient because, again, they're numbers in front of variables. All right, and another small thing that's not here, but this number, this coefficient in the front would be called the leading coefficient, if you ever heard that word. All right, one last thing is constants. Basically, constants, you can think of them as just numbers by themselves that don't have any variables attached to them. So -4 here would be considered a constant. Good. So yeah, those are some words you'll maybe hear throughout the year. So just keep in mind, that's what we're talking about. Okay. So with this in mind, we're going to be doing a lot of kind of combining like terms. So kind of a continuation of the end of yesterday's lesson. So let's go ahead and try it out. Okay, we're going to combine these like terms. All right. Yeah, go ahead, copy this down, and then I'll actually get into it. Take a second. Okay, so first things first. What does it mean to have like terms? I kind of brushed on this yesterday, but like terms are terms that have the same variable and are raised to the same power. All right. So if I have, for example, an x to the power of 3, I can only combine that with other x's to the power of 3. I can't combine it with x's to the power of 2 or x's to the power of 4 or y's to the power of 3. Same variable, same power. Okay, so when we go to combine these like terms, all right, first things first, let's just point out we have 1, 2, 3, 4, 5 different terms here. Okay, we're going to combine like ones. When you go to combine like terms, start with the term that has the I guess alphabetically, the earliest variable to the highest power. Okay, so I'm looking at this saying I have some x's, but I also have these y squareds. Okay, and if something has a higher power, that's what I want to start with. So I'm going to start with this y squared, and I'm going to notice, oh, I have another y squared. I can combine these. These are like terms. Okay, so I can do a 7y squared minus 5y squared. Remember that minus is part of it. Okay, so 7y squared minus 5y squared gives me a 2y squared. Okay, notice we just subtracted the numbers. The exponents, they did not change. Stayed a y squared. Okay, another thing I mentioned yesterday, it's not a bad idea. Once you combine some terms, cross them out. We're done with those. Okay, now I'm going down the line and I'm noticing, oh, I have some x's now. All right, looks like I can combine them. A 9x and a positive 3x. I can combine those to get a positive 12x. Okay, and again, let's cross them out. Okay, crossing out is nice, especially when we get to problems that have a lot of terms, because now it's kind of obvious. All we have left is this -2. There's no other constants here to, I guess, combine it with. So we can just bring that -2 or that -2 down. And there we go. Okay, last thing, just double check. Do I have any more like terms that I can combine? Okay, and the answer is no. So I know I'm done here. And let's cross out this -2. That bothers me. Okay, so pretty simple continuation of what we were doing. Let's keep going. Okay, let's try it again. Same directions. You don't need to get these again. If they repeat, you don't need to keep writing the same directions. Okay, so take a minute, go ahead and copy these down, and we'll combine them together. All right, so first things first. Looks like we have 1, 2, 3, 4, 5, 6 terms on this one to combine, or potentially combine. Right, so I'm looking for my variables that have the biggest exponents, and I'm noticing I have some x squareds. We're starting there. So a 7x squared minus 2x squared, looks like we're getting 5x squared. Okay, cross them out. All right, moving down the line, I don't have any variables with squareds in them, so I'm kind of going down the list. Okay, looks like I'm looking for, looks like I have some x's and some y's. All right. The question is which should I write first? Okay, well, I'm going to start with the x because it comes earlier in the alphabet. Okay, so I'm looking around. Are there any other x's to combine this 5x with? No, there's not. So it's just going to come down. Okay, cross it out. Okay, looking for any other terms that have variables, and looks like I have a negative y squared, or sorry, just a negative 7y. I don't know why I said y squared. There's no other y's, as you guys can see. So again, this is just going to come down. Okay, cross it out. And last thing, it looks like I just have a couple constants left over. Negative 10 plus 3. Looks like I'm going to get a negative 7. Okay, and let's cross them out. All right, we've combined everything. I'm looking down here and I'm wondering, can I combine any of these terms together? Can I combine a 5x squared with a 5x? Hopefully you're thinking, no, Mr. Stone, they're not like terms, all right? Because this is not x squared. It would need to be a 5x squared to be able to be combined with these x squares. Okay, so no like terms here. That's how you know we're done. All right, let's keep rolling. Okay, so I'm going to give you guys a chance to try this on your own. Go ahead and copy this down. Directions repeat. You don't need those again. And try it out. Okay, go ahead. Okay, so taking a look through this problem, it looks like we have 1, 2, 3, 4, 5 terms. Sorry, I'm restarting my board. There we go. So we got 1, 2, 3, 4, 5 terms here. All right. I'm looking through these and I notice, oh, I've got some y squareds and I got an x squared. What should I start with is kind of the question. Okay. I'm going to start with the x's. Okay. Because again, it's earlier in the alphabet. All right. They all have squared, so they all kind of, are in the same category there. Okay. But let's start with this 3x squared. I'm noticing no other x squareds. So let's write that first. Okay. Just bringing it down. Can't combine it. Cross it up. Right. I have my y squareds. Okay. A couple of them. Those are like terms. Let's combine them. Okay. Negative 3y squared plus 2y squared gives me a negative 1y squared. Okay. By the way, a lot of times when we have a 1 in front of a variable, it's not written. Okay, so you might instead write this as instead of negative 1y squared, just as negative y squared. Okay, it's normally the way it's going to be written. It looks cleaner, but just know there's always that invisible 1 there when a variable is by itself. All right, cross them out. Last thing, couple constants, negative 7 plus 9. Just remember, guys, you can always read things in reverse. This is also a 9 minus 7, which might be easier to understand. Positive 2. Okay, so yeah, there we have it. No more like terms. I know I'm done. All right, we're moving along. Cool. So now we're going to get into questions that are asking us to simplify. Okay, if you ever see directions simplify, they just mean do all of the math that you possibly can. Okay, multiply, distribute, combine like terms, do everything you can. Okay, so yeah, I do notice we have distribution. We have, two things we can distribute. That's what we want to start with. Okay, before we, do anything else. Which, by the way, I guess technically what we want to do is look inside of our parentheses and see, oh, can I actually add these two things together? If this was a 6, I could just add it and get a 15, right? So, I look for that just like subconsciously, but we can't. So let's go ahead and distribute. So multiplying the 4 times these two terms, and I'm also going to do the same with the negative 3, all in the same step. Okay, so 4 times n gives me a 4n. 4 times 9 gives me a positive 36. Moving on to this one, negative 3 times 2 is a negative 6. Negative 3 times n is a negative 3n. All right, so you might be thinking, okay, sweet, we're done. Let's put a box around it. Okay, remember, always look for like terms. And it looks like, oh, we actually do have like terms we can combine. All right, starting with my variables, I have a 4n and a minus 3n. Okay, 4 minus 3 gives me a 1n. All right, but just like I was saying before, we probably wouldn't write that as a 1n. We'd probably just write it as n. Okay, that 1 is implied. Okay, cross them out. Okay, last thing, couple constants, 36 minus 6, positive 3. Okay, no more like terms. I can't add these together, so we're done. Alrighty, moving along. Cool. I'm gonna have you guys go ahead and try one of these out. Distribute, combine like terms, and then we'll look it over together. Give it a try. Alrighty. So starting with the distribution, distributing the 5 into this one, the negative 2 into this parentheses. Let's see what we got. 5 times 6 got 30. 5 times n is a positive 5n. Moving on over here, negative 2 times n is a negative 2n. Negative 2 times negative 2, positive 4. All right, you guys know we're not done because you probably noticed we've got some like terms. All right, starting with our variables, 5n minus 2n looks like we're getting a 3n. Cross them out. 30 plus 4, 34. Cross them out. All right, last thing, cannot combine these together. We're done. All right, so yeah, that is our lesson here. Short and sweet. So yeah, hopefully you're feeling good on this, and I will talk to you guys in class. We'll see you.